Okay, transformation and dilation, reflection, and translation on different functions. Easy way, Dr. T. We look at in a matrix format and without a matrix format. So with a matrix format, this is going to be how it will look like, and whereby the diagonal here, A and B, are translation, and so they are dilation and reflection, whereby this section, whereby this, that is translation, and the translation left or right is A, whereby B is up or down on the y-axis. Okay, so in a matrix format, this is how it would look like. Reflection in the x-axis, where reflection in the x-axis changes the y, whereby reflection in the y-axis changes the x. So that does happen. So if it's in a matrix format, so it goes with the dilation factor of x from the y-axis. Our dilation factor, which is this is here, that we put it in a fraction format, a dilation factor from the y-axis. A dilation factor from the x-axis, or parallel to the y-axis, will change the f of x function, whereby a reflection in the line y equals to x, it swaps the x and the y, which is what you have this diagonal here. Alright, let's have a look at different examples on this, and to make it more sense of it. Where the k, which is stretches, which is it either stretches or compresses the whole graph, where the b translates up or down, left or right, the c translates up or down the whole function. So a negative with the x is a reflection on the y-axis. Alright, let's have a look at this example here. The first example, a function f of x is translated 4 units in the positive x direction, reflected in the y direction, in the y-axis I should say, and dilated from the x-axis by a factor of 3 in that order. So the order that has been given, that's what it means. The point R is on the graph. What are the coordinates of the point S to which it is transformed? So R is transformed. So let's do it step by step. So the first is translation, in this case here, translated 4 units in the positive x. So that means we're adding the x value 4. So that means negative 2 plus 4. Alright, so that gives me 2y. And now here, from here, we've done that. So reflection in the y-axis, so that changes the y. So reflection in the y-axis, that changes the x because it's the opposite. So that's going to be x will be negative. The x value will be negative. A dilation factor from the x-axis changes the y. So my final value will be negative 2 and 27. So we multiply 3 on the 9. Alright, and that will be the coordinates for S. Negative 2 and 27. Alright, let's have a look at another example on this transformation. Okay, so we have point B. It looks like I've written a couple of times. Point B is dilated by a factor of a half from the origin, then translated 4 units to the left, 4 units left, and 2 units up. What is the final coordinates of the point? So, alright, so that's going to be half times 1 times a half as well. So that gives me a half. So that is translated 4 units to the left. So that's going to be a half minus 4 and a half plus 2. So that's going to give me negative 7 over 2, 5 over 2. So that's how we do that example as we can. Alright. Okay, so let's actually have a look at the scenario whereby we have to explain what's going on now. Okay, now we have a function state the sequence of transformations to which transform the graph y equals to tan x to the graph y equals to negative 2 tan x over 4. Alright, so now we have to explain how we got into that. So that is definitely going to be a dilation factor of 2 units from the x-axis and a reflection on the x-axis. So we still follow the Dr. T. So we start with the dilation first. So dilation of factor 2 from x-axis, and also we have got a reflection followed by a dilation factor of 4, because we have to reciprocate the dilation factor from even though it's a fraction, we reciprocate a dilation factor followed by the dilation of factor 4 from y-axis. Okay, we're done with the dilation and reflection on the x-axis. And a reflection. Then a reflection on the x-axis. Okay, that's how we do that example. So let's have a look at another example, which is basically the same sort of thing. And we will have a look at a scenario whereby we have to go back and change all the sequence. Alright, state the sequence of transformations which transform the graph y equals to cos x to the graph y equals to 6 minus 5 cos 3x. Alright, the dilation factor, so we always start with the dilation. Alright, a dilation factor of 5, a dilation of factor 5, from the x-axis, followed by a dilation, followed by a dilation of factor a third from y-axis, or parallel to the x-axis, could be another way of saying it. All right, and now we do the R now. So Dr. T, R, so reflection on the x-axis, and a reflection in the x-axis, then we finish with the translation. Then translation, a translation of 6 units up. And that's it. All right, let's have a look at another example. So this time a translation. All right, so now reflection on the across the line y equals to x. So in this one here, so the x becomes the y, so we swap the x and the y. So that becomes x, the image, I should say. It's going to be negative 6 and 2. So that is how the reflection will look like. All right, let's have a look at another example on this transformation, because transformation is something that we definitely need to understand how it's done. All right, I think this is exactly the same as the one I've done before, so that is similar. We have got a dilation factor of 5 units from the x-axis and a dilation factor from y-axis, which is a third. All right, let's have a look at this one here. So this time we're actually going to go back. So describe the transformation that have been applied from 3 over x minus 1 plus 2 to, so this time we're actually going back. So in other words, we want to have to do it, undo it. Alright, so now there is actually a dilation factor from the y-axis, from the x-axis, so we need to do the opposite. So in order to get to this, we need to do the opposite. So dilation factor of y, of 3 units from y, and a translation of 1 unit, so we always have to do the opposite. So that means, so 3 there, x minus 1, so that cancels out. Just get a different color. So a dilation factor of 3 units from the x-axis, so that is what I'll end up getting. So I should say a dilation factor, a dilation of factor 3 from x-axis, and then translation of 1 unit right. We want to get rid of the negative 1, followed by a translation of 2 units down, of 2 units down to get. State the new rule when the following transformation is applied to y equals to sine x dilated by a factor of 2 units from the y-axis dilated by a factor of 3 units from the x-axis, translated 2 units down and by over 12 units to the left, and then reflected in the y-axis. So this is the best option, is to do in a matrix format. So let's say x bar, y bar. So that's the image. So the matrix is, the diagonal will be my dilation factor. A dilation factor from the y-axis, we put it as a fraction. So this diagonal will be 0. So dilation factor from the x-axis changes the y. So that's x, that's y. Plus we add the translation. So it has been translated and pi over 12 to the left. So that's going to be the negative pi on 12 and 2 units down. Reflection on the y-axis. Reflection on the y-axis changes the x. So let's get x, the image. So we multiply, we multiply this to that. So that means, so row, so this is how we multiply, and that row to this column, and likewise we do the same thing again. So let's do this one here. So x bar is negative a half x, 0 times y is 0, plus negative pi over 12. Alright, now we make the x the subject, but before we get into that, let's get the y the image. So y the image is 0 times x is 0, plus 3 times y is 3y, minus 2, so we add that. Okay, now we need to make the x the subject because we need to go back to the original function, which is y equals to sine x. We replace the y with the new y, the x with the new x. Alright, in doing so, that means if I make x the subject in this case here, x the image, so that's going to be pi on negative. So that's going to give me negative 2x pi minus pi on 6. And that is my x. And my y will be doing the same thing again. So y in this case will be y the image plus 2 over 3. So we go back to the original function and make y the subject. Alright, so my original function was y equals to sine x. Alright, now substitute. So y image plus 2 over 3 sine. So now the new x is basically negative 2x bar minus pi on 6, and make y the subject. That's why your image 3 sine, Take the common factor out, so that's going to be x bar plus y on 12. Then the 2 take it the other side. So that's how it will look like, the new transformation. Using the matrix is much easier. I hope that's clear.